Okay, so we're gonna move on to combination circuits. You guys know the difference between series and parallel.
Yes.
Yes, correct.
Okay, combination circuits are be a little bit different. So what you have to do in order to figure out total resistance, you have to break it down and you have to make it either a series or parallel circuit. Okay, so if we take a look at a combination circuit, what do we have here? Can you see that is a combination circuit?
Yeah.
Can
Okay.
you see there's elements that are in series and there are elements that are in parallel? Does that look confusing to you?
Yeah.
Yes.
Okay, so we're gonna break it down and we're gonna make it simple. And this exercise is good for you because when you look at a schematic, a lot of times you're just gonna have to simplify it. Okay? Okay, so what do we got? What do we got? What do we got?
All registers
Yeah,
are 25 ohms.
All resistors are 25 ohms, that just makes it easy. So, looks like we got, what this? Are these two in parallel?
Yeah.
No.
No, the
Series.
parallel ones are
Series.
like the layered ones.
What were you saying about going back to Magic Box class?
Ah, okay.
This is in, what are these two?
Series.
Series? And these are in what? Parallel?
Also series.
Okay, then these are all
Parallel.
kind of. Kind of. Because we got one in here that throws everything off the mix, okay?
Nobody there. Yeah, there's no one but.
You just like waving it?
Yeah, we just like to wait. We
Okay.
just like to wait around.
Alright, so first thing we gotta do is we gotta simplify it, okay?
Mhm.
So what are we gonna do first?
Break it down.
Bring it down to one series.
Okay. Look, check this out. Go back.
What?
Check it out. What did we do? Look at our 7.
What are you gonna do?
Are those in parallel? There's 3 right there, right?
Yeah.
What'd you say these 2 were? There's 3 there,
Yeah.
okay? You see those 3?
Correct.
They're all in series, right? So, our 7, 8, 9, if you add them up, what do you got?
Oh, it's
75.
Because they're in series, right? Okay. Okay, so let's do, what's the next one? Oh, we do R6 and R5. And those 2 are 50 ohms, right?
Correct.
Okay. So what are we gonna do with this mess over here?
Are you gonna
Let's
bring
take
them
a
up?
look.
Put 2 and 3.
Don't-
I think
oh,
Floyd.
Look, we moved
No,
out
I
and
think
down
we're gonna
there.
put.
Did you
two,
see
yeah,
that?
I
Did you
think
see
we-
that?
I saw it, I didn't get
Oh.
it.
Did you see it?
Nope.
Oh. There?
Those are-
These 2 are parallel, right?
Yeah.
Oh.
That makes more sense.
So,
No.
if they're in parallel, then that means that we can get a value off of that, right?
Okay.
Okay, so we eliminated that, so what do we got now? We got these 2 in series, in parallel with these 2,
Correct.
okay? So, let's see what it. Oh.
Wait.
Oh. Wait, what kind of sorcery is that?
I know.
I don't know.
I'm trying to figure that out.
Go back to truck up. R4 and our 30 ohm value over here for
Okay.
those 5 resistors, right?
Correct.
I'll say it again. What manner of sorcery is that? So we basically have those 2 in series, right?
Uh-huh.
Those 2 values, right? And that's gonna equal what?
No, wait. Oh yeah, 55.
55. Okay, so we make it all 1.
Correct.
55, you were correct. 55.
I'm a mathematician.
Okay, so these 2 are in series, so we're gonna have to add those up too. So those 2 added up are what?
50.
Okay, so these two are in parallel now,
Mhm.
so we got a 50 and a 55 in parallel. Okay, so if we, put them all together, what do we got?
26, 20.
26.2, so our 2, 3, 4, 5, 6, 7, 8, and 9, the value of those are 26.2 ohms. In
Continue.
series or
Series.
parallel?
Series.
So we have to add that one to that one, right?
Correct.
Because it's in series. So this breaks down, and this ends up being a simple series circuit. Wow.
So you just combine all of them in a way?
Huh?
You could just kinda like for the
So-
parallel first, and then the series, and then parallel again?
Sometimes,
So the
depending
parent.
on the circuit, you have to, whichever one is gonna be simplest, so.
Wait, so on the parallel ones, we have to divide them?
What?
On the parallel?
What parallel?
Parallel circuits? Do we divide them then to the other parallel one? That's how you got the answer.
No, depends on the value. Depends on the value. You're gonna divide. So how do you figure out parallel circuits?
The current,
Huh?
by the current.
No, was it? There were some of the
Oh, yeah.
reciprocals reciprocated. Some of the reciprocals reciprocated.
Okay.
Have you been practicing that?
What?
Saying that?
Oh,
Did I tell you about the guy who worked at NASA? There was a guy that worked at NASA, that worked here. He taught this for IoT and for HVAC. And I talked to him, I said, you know, that's what I call that formula. The 1 over 1 over 1, 1, 1, 1 over?
yeah.
I said, I call it the sum of the reciprocals, reciprocate. I said, is that right? He goes, yeah, we can call it that, but they don't call it that.
What do they call
I
it?
don't know what they call it. I'll never remember it, they tell me, so. It disappeared. Go ahead, say it again. What manner of sorcery is this? We're gonna look at another one. Okay, simple, 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 right? Look,
Right.
all resistors are 500 ohms. Check
Okay.
it out. Okay, A and B is what you need to look at. So the power comes in A and B.
Okay.
So you're gonna go from A to B. So if you look at it like, you're gonna travel, this is a road map. You're gonna travel from A to B.
So it's a one-way street type of thing.
Yeah, you can look at it in one way. Even though alternating current is going back and forth, you still have to make a path for it. So if you just kind of think of it, oh, I'm gonna go this way, and I'm gonna go this way, right? So, if we do that, we're gonna redraw this. Because of that, we can redraw this. So I actually took this point here and I moved it up here
Okay.
to make it look simpler, right? And then I can actually take this point right here and move it up here. So it looks normal.
So it's
More
parallel to each other?
So it looks like it's a parallel. I'm taking this, and I move the resistors up here because that's where they are, right?
Correct.
So I'll move the connections up to there. The same circuit, right?
Correct.
I just redrew it so it's more easier to understand or follow, right? So you're still going from A to B, right?
Correct.
Okay, so we're gonna look at them, we'll make those two 500s, you add those two 500s up, you see that? You see that? And we made 1,000 ohms, 2,000 ohm in parallel. So this reduces down to the simplest form is a parallel. The last one was reduced down to a simple form of series. Okay? So, in this case, your total resistance is 500 ohms. You seeing that? Yeah, pretty
I
simple.
see what type of sorcery is this?
It's pretty simple. But it has to make you think. Okay, and it's conditioning you into thinking into two-dimensional.
Yeah.
So we're entering into the two-dimension. A little bit later on, we'll go from two to three-dimensional.
How high did we go then? On dimensions. Sorry. Like how much?
There's
dimension?
only three.
There's only three. I didn't.
That we
that's-
deal with. There's only three.
Okay. I thought it would be more. This is the way